All right, so this is gonna be question 4, Chonky slimes. And so basically the question asks, you are a dev on team making Slime Rancher 3, and we're implementing a new feature, slime weight, which basically determines how quickly the slime gets hungry again. And you're faced with this problem where Beatrix is shooting out slimes, the backpack shoots out lighter slimes, first to consider better view. And they give you an example here that if we have added a slime weight of 8, 1, 5, and 2 in that order, the first to be removed with a slime of weight 1, implement a priority queue for the vax packs using a slime array, mini organized by slime weight. You can use fewer lines than given, but not more. So yeah, let's just kind of get into the problem. So first things first, we want to kind of go over these different variables we have. So we have the slime class, and we know each of them is going to have like some sort of weight, as we can see here. These are the weights for the other slimes. And then we have this slime array, which is going to be keeping track of our priority queue. And we have this constructor, which basically just slime array and sets the size. And then this is going to be like the max size. So it's going to make like a array of like arbitrary size based on like the max size. So yeah, kind of let's just get into like an example here. So I kind of drew out this little thing where basically this would translate to this if we like put it into priority queue and stuff. So kind of going through it. So actually this would be class object slime. I just drew it out with numbers just to make it a little bit easier to visualize and like understand. But yeah, so these would be like the weights of each slime. And then this would be how we translate to tree. And remember, the way we can do this is we know that these would be the childs of 1, these would be the childs of 2, and then 5 would have no children. Okay, cool. So they say implement the add method for slime PQ. Assume we will never attempt to run add when we have the max number of slimes in our priority queue. So I think upon initial glance, it's gonna be pretty tough to look at. And so I think the first thing we should kind of just work through how this would work. So I'm just gonna erase all this. So let's just say we're adding a number, say add 0. So when initially adding 0, we'd want to add it to this. So we'd first add it to the end like this. So it looks something like this. And then I'm gonna go through the tree version, and then I'll go through how we do like an array after. So yeah, we add 0, and then we want to swap it with 5 because we know that 0 is less than 5, so it should be higher than 5. Or like it shouldn't be, sorry, not higher necessarily, but 0 should not be a children of 5 because 0 is greater than 5, less than 5. So it should actually be the parent of 5. So we swap it. And then we also see that 0 is less than 1, so we want to keep on going. And then now we know we've reached the root. So obviously, because we're at the root, can't really do anything else. So we want to return. Okay, and then the way we work in here is we basically want to swap. Again, 0 with 5. And then 0 with 1. So that's what our array would look like. And then just for like good understanding before we hop into the problem, one thing we want to notice is that the relationship between, so I'm going to revert it to the original array. So the relationship between 0 and 5 and like getting the parent in general is we want to take this index and then divide by 2. So in this case, we do 6 divided by 2, which equals to 3. And let's just say we want the parent of 4, just for like conceptual understanding. So we do 5 divided by 2, and then this would round down because we know this would Java division works, and then that'd be 2. So yeah, we can kind of get into it. So I think the first thing we want to do, and I'm going to go back to this tree example. 0, 5, 1. So the first thing we want to do is we want to add like 0 right here. So let me just erase all this. So we want some way to keep track of where we're putting this new 0 in the array. So we put in this like last spot here, and we know we had a size 5 already. So we want it to be size 5 plus 1 is that's going to be the new spot for our 0. So we have this size variable. So we're going to do that. Plus 1. And then we're going to add it to our array by doing PQ switch index equal to fine. So basically what this is going to do is just like, we know we already have an array of size 5. And so we want to add it to the 6th index. So right here. And then it's just going to insert that 0 right here. So our array is going to look like that. And then the other thing we do, I kind of went over it, is that we're going to be doing a lot of switching. So we're going to want to keep track of some sort of temp variable, some sort of way to keep track of like what we're switching, that sort of thing. So I'm just going to declare some slime temp. And then this is kind of just like a good rule of thumb when we're doing these switching problems. You often want to keep track of some sort of temp variable just to kind of know what you're switching with and that sort of thing. So yeah. So the next thing we want to think about is that in the case of like 0, so if we had this, once we get to this root, we're going to want to stop because obviously we can't go any higher. And then the way we can do this is basically just like by just saying like when we get to this index 1, because we know that it's like it starts at 1, we just can stop. So that'll be our while loop condition. So we want to, so while it's not equal to 1, we'd want to keep on going. So the first thing we need to know is that when we're swapping, let's say, sorry, keep on, can we go back? But so we're doing this, not this. So when we're doing this, we'd first, oh, sorry, it's not right. There we go. So we first want to check if 0th weight is less than the weight of 5. So essentially, we want to check if the child's weight, or like, the current index we're trying to bubble up, is less than the parent's weight. So the way we can do this is first by, we can get the switch index because we know that's the weight, or like that's the node we're tracking already, and like we're thinking about bubbling up. So that'd be like the 0th node here, and then obviously that'll correspond to the 6th index in this case. And then we want to check if it's less than the parent's weight. And the way I talked about it is we can basically just do whatever index we're at and divide it by 2, and then that'll be like the parent's index. So in this case, it'd be 6 divided by 2, which is equal to 3, which gets the parent index. So I'm just going to call it switch for short. Switch divided by 2 dot weight. And so in this case, we want to make a swap. So the way we can do this is we first need to keep track of like, we need to store this temp variable. And we need to keep track of one of their weights. So in this case, I'm just going to keep track of the parent. So divided by 2. And then sorry, I misspoke. Not their weight. We need to keep track of like the parent slime. So yeah, so we keep track of the parent slime like this. And then now that we have a pointer to this, we can switch it in the priority queue. So priority queue switch 2. And again, we're going to want to, in this case, we're going to switch it with 0. So it's going to look like this. We're going to want to set it to 0. And then lastly, we're going to want to switch back to the parent. So switch. This is going to be equal to temp. So it's going to be equal to this 5. So it's going to look like this. And just kind of for visual understanding, it's going to basically like go like this, where we sort temp, and it's going to be equal to like some slime object, which is going to have this 5 in it. And then we're going to set this to 0, or like slime of 0. Remember, they're slime objects, but I'm just doing numbers for sake of understanding. Okay, fine. So yeah, we set it to 0, and then we're going to want to then update this and set this to like temp, which is going to be 5 for sake of understanding. So yeah, and then from there, we're going to want to see if we keep on going. So we basically just set it to this. Because this is going to be the new index of the node we're adding, or sorry, this is going to be the new index of the node we want to know if we have to like bubble up. Otherwise, we would just break out of the while loop if the if condition fails, and then we're going to want to increment size, and then we can just return because we're going the array, so we increment size. So yeah, I hope everyone found that helpful, and yeah, have a good one.